This is problem 7-63 from section 7.1.4. Sketch a unit circle. In your circle, sketch in an angle that has all of these different things. We're going to talk about 5 different situations. So I have 5 different circles just so it's easier to look at one circle at a time. So for part A, this will be our circle for A. So we need to have a positive cosine and a negative sine. So I'm going to draw on my horizontal line right here. So positive cosine means my horizontal distance is going to be on the right side of the center pole. Right? If it's negative cosine, that would mean it's on the left. So positive cosine is over here on the right, and a negative sine, which means it needs to be going down. Okay, it needs to be going down somewhere. It has a negative distance vertically. So any spot kind of in here is going to work for that. I'm always going to be going down to have my distance, and I'll have a positive horizontal distance. So anything in the 4th quadrant is going to work for part A, any angle. Part B, a sine of -1. So this is talking about my vertical distance is down 1, exactly one thing below the ground. So that is my my vertical distance is going to be down. So that I know that was down here. These are getting bigger, closer to -1 here, but right here is where it is straight down. So this angle right here, if I went all the way around, this would be 270 degrees. So that is when I have a sine of exactly -1. Okay. So part C, I have a negative cosine, which means I'm to the left, and a negative sine, which means I'm down somewhere. So anything in this area is going to work. So that's going to be my 3rd quadrant. Anything in my 3rd quadrant, if I want to have it be 200 degrees. Right, if this, say, is 200 degrees, it is to the left of center, and it is down. So anything in the 3rd quadrant will work for part C. Part D, it says a cosine of about -9, or -0.9, sorry. So let's look, that's to the left, I know, and it's pretty long, so it's going to be not quite all the way there, but it's going to be, change my color here. So it's going to be about to maybe there from the center. Right? If it was 1, it would touch that end. So I'm in the red now. And it has a sine of 0.4, so that means my vertical distance is kind of small-ish, but maybe bigger than halfway up. So here's about what my angle is approximately. So again, I'm going to start from 0 degrees over here, and it wants to know kind of what is this whole angle, and I guess we're just thinking about where is this in the circle, where is this in the unit circle. So I'd say that's about, I know the green line is about 180, so I'm going to say that's like 160 degrees approximately. Okay, so I know if it's a negative cosine, that's in the left direction. A positive sine is going to be somewhere in my 2nd quadrant, and I'd say it's approximately 160 degrees. Part E, could an angle have a sine equal to 0.9? So let's try to draw that in. That's going to be positive. Whoop. It's going to be positive, so I know that's going to be, so here's this. It's maybe like here, because straight up and down, this part would be a 1. That would be a 1 right here. So it's going to be not quite straight up and down like that. And a cosine equal to 0.8. That means my horizontal distance this way has to be almost touching the edge of my circle. Okay, so if I'm going to continue in the green, I'm going to go up and hit my circle right there and down like this. So this is taking into consideration the cosine. If the cosine of theta is 0.8, it would be the green guy. Now this distance right here is not almost to this height. Right? This is shorter than that. So 0.9 is pretty darn close to 1. But this is smaller than that. Okay? So that is a concern right now. And let's put our stuff back on there. I just wanted to clean this circle off. So now if I just focus on the sine, I want my sine of theta to be 0.9. So that's straight up and down. So if I'm straight up and down, that is pretty close to here. So I'll draw in my triangle. This distance right here is very close to 1. So look at this triangle. Now what this question is asking us, we saw just focusing on cosine, it was kind of not sure. Is this little angle, this little distance right here, is that where it's about 0.8? Is that possible? Have that short little distance be about 0.8? Now 1 would be all the way to this, from the center to the end over here. So if I'm thinking, is that possible? No. So if I have a high amount for my sine, that means it's going to be a really steep triangle. So if we have sine of theta is close to 1, it's going to be very steep. So therefore I have a small horizontal distance. Which is also cosine. So I know my cosine of theta would have to be very small. So it's not possible to have both my sine and cosine to both be very large, okay? Because the steeper I get in my measurement right here, the smaller my cosine gets, right? Vice versa the other direction. If I have a longer horizontal distance, the shorter the height gets. So it's not possible to have large values of sine and cosine in this circle, okay? So that's how we're visualizing weird things happening on the unit circle, and I cannot have two large values, or in another case, I can't have two small values of sine and cosine to be the same angle.